All right, and lastly for this day's worth of notes, you are going to look at, it's going to give you some problems and it's going to ask you things like, is this particular point a solution to the system? You have two choices. You can either take the two equations that are given to you and solve them by either substitution or elimination, or graphing them and seeing if that is indeed the point where those two lines would intersect, or probably easier than that, you can go ahead and substitute them in. Okay, so 2 is your x value and -3 is your y value. And so you're just simply going to literally plug those in, but you have to plug them into both equations. Okay, so I'm going to check the top equation first. I will plug 2 in for x, and I will plug -3 in for y, and I am going to see if I end up with a true statement. So 2 times 2 is 4, -3 times -3 is 9, and 4 plus 9 does indeed equal 13. So 13 equals 13. I have a true statement, so it worked for the top equation. But just because it works for the top doesn't mean it's a solution. If it doesn't work for the top, it's automatically not a solution. But if it does work for the first equation, you still have to test the second one. Okay, so now I will test the second one. And again, I will plug in 2 for x and -3 for y. So -5, x is 2, y is -3, and it's supposed to equal -14. So I'll check that. So -5 times -2 is -10, and 2 times -3 is -6, and -10 minus 6 is -16, and it does not equal -14. So because 2 -3 does not work in both equations, then it's not a solution. Okay, if it worked in both, it would be a solution. As long as it doesn't work in one, it's automatically not a solution. And this one didn't work in the second one. Okay?